Hi, welcome to the series How to Solve Problem Using Computers. In this video, I am going to teach you a logic for sum of natural numbers. How to solve this problem, sum of natural numbers using computers. First, let us understand the problem. Suppose your n is equal to 5. What we are supposed to do? We need to add 1 plus 2 plus 3 plus 4 plus 5 and store the result to sum. How to solve this using computers? So in a computer, whenever you wanted to add some values, these values must be available in the memory. So in this case, you have 5 values, which means you require 5 storage locations for to store these values. One will be stored in one memory location, let us name it as A. 2 will be stored in another memory location B. 3 at C, 4 at D and 5 at C. After storing this, we need to add all these things and store it in sum. So sum equal to A plus B plus C plus D plus E. So this is the process you need to do. And your final value, that is the result, will be stored in another memory location, that is referred by sum. But in this case, you have only 5 variables, that is 5 values. So you stored in all the 5 variables and you performed the operation. What if n is equal to 100? So where you will be requiring 100 memory locations where you will be storing the values from 1 to 100, and then you need to perform this summation. So this is not an efficient way of approaching the problem in computers. So in computers, let us see what is the logic followed. So we'll just see here. So we'll use a variable sum, which will be initialized to 0, and we'll have another variable A, which will keep track of the values present in the sequence. So you observe the sequence. The first value is 1 and the next value is addition of 1 to the previous value. So addition of 1 to the previous value, that is 1, you get 2. The next value you will get by adding 1 to 2. The next value you get adding 1 to 3, like that. So we will keep track of these values using a single variable, that is A. So whose value will be 1. Next what we do is, we will just do sum equal to sum plus A. So initially sum is 0 and now the value of A is pointing to the first value. So 0 plus 1, you will have 1. So that will be stored in sum. So sum becomes 0 plus 1, 1. Next what we do is, we will make use of the same variable to refer the next value. So next value is nothing but 2. So how do I get this 2? I will add 1 to the existing value. So where I will represent this as A equal to A plus 1. So my previous value is 1. I am adding 1 to it. So I get A is equal to 2. So I get A is equal to 2. Next what I need to do? I need to add this 1 and 2. That is sum equal to sum plus A. So again I call the expression sum equal to sum plus A, which will give me the value 1 plus 2 is equal to 3. Next again what I need to do? I have to make my A to refer the next value. So referring next value is done by A is equal to A plus 1. So on referring, this 2 will be turned into 3. Next again what I do here? Now again I will add sum equal to sum plus A. So 3 plus 3, it should become 6. So sum will be replaced by 6 now. So I get 6. Next again I proceed by incrementing my A value. So a is equal to a plus 1. So I am referring to 4. And now next I add these two values and store it in sum. So sum equal to sum plus a. So 6 plus 4 I get 10. Then again I increment my a value to refer the next value. So a becomes 5, and then again I execute sum equal to sum plus a, where 10 plus 5 I get 15, and I will stop because that is the last value. So now this logic, as you can see in the previous method, I used individual variable for all the values, which made me to use more number of variables. But in this logic I am using only two variables, sum and a. So it minimizes the space required for solving this problem. Now let us write the logic. So how do you write the logic? So in a logic you need to represent what is your input for your problem, what is the process which you are going to do, and what is your output. So the input is, the problem is find the value of 1 plus 2 plus 3 plus up to n. My input is, you should know what is this n, that becomes your input. Next, what is the process we have done? So first I used a variable to store the values of the sequence. So that variable I just named it as a. Initially a is equal to 1 because it is the first value of the sequence. So I am using a to refer these values present in the sequence. Similarly, I used a variable to store the resultant summation. So that variable I named it as sum, and initial value of sum is 0. Next what I did, I add this a value to sum and store the result in sum. So how do I represent? Sum equal to sum plus a. Then what I did, I want to get the next value. The next value is nothing but 1 added with the previous value. So how do I represent? It is a equal to a plus 1, because I am using this variable a to refer these values, which is initialized to 1. So a equal to a plus 1 means my previous value is 1. I am adding 1 to it. So now my a becomes 2. Now I will be repeating this process, sum equal to sum plus a and a equal to a plus 1, until a is greater than n. Okay. Now after, once a becomes greater than n, then the process should halt and your output will be available in this variable sum. Okay, that is what we saw in the previous slide. So let me also explain this process for n is equal to 5. As you have looked into it, what we are doing is sum is initialized to 0, a is initialized to 1, and I am repeatedly processing sum equal to sum plus a and a is equal to a plus 1 until a is greater than n. So remember this. So let me just show you here. Sum is 0, a is 1. Let me just go slow by slow. So sum is equal to 0, a is equal to 1. Then I am adding these two and I am getting 1. I am incrementing a, I am getting 2, and I am adding these two, I am getting 3. Then again a is incremented, I am getting 3, then 3 plus 3 is added, I get 6, and a is incremented 4, and 6 plus 4 10, and then 5, and it is added, and I am getting the resultant sum as 15, that is stored in my sum. Now next we need to write the algorithm. So whatever you have identified and represented as the process, that you need to represent as the algorithm. So it starts with the steps. So the first step is start. Step 2 is you are reading the value of n. You need to know what is n, that is input. Next, step 3, you have to initialize a to 0, sum to 0. A to 1, sum to 0. Then you have to repeat something. So what you are going to repeat is, I am repeatedly computing sum equal to sum plus a and I will be incrementing a by 1. These two steps are repeated. So I have written repeat steps 5 to 6. How long? Until a is greater than n. So if it is greater than n, it will come to 7 and it will display the sum, and then you need to stop. So this is the algorithm. Now you look at here, step 2 is reading the value of n, step 3 is initializing a to 1 and sum to 0, and step 4 is you have to repeat something until a is greater than n, which means that it will just check a is greater than n or not. If it is not, then it will do the steps 5 and 6. Okay. Again, after performing this 5 and 6, again it will come and check whether a is greater than n. If it is false, then again it will come and check. It will come and do 5 and 6. Again it will go and check. So this is how this process will be repeated. This is what in computers we term it as a loop. Then once a is greater than n, it will come out and it will come to the step 7, which is displaying the 7. So now let us execute this algorithm. So how to execute? Remember, step 2 is reading, step 3 is initializing, 4 is checking a is greater than n. If it is no, then it will just come and execute sum equal to sum plus a and increment a by 1. That is nothing but a is equal to a plus 1. Okay, so if it is a is greater than n, it will display the sum. So we will see how this algorithm can be verified. So first you write down the steps, and then what are the variables you have used. We have n, we have sum a, and we need to test a condition in your algorithm, a is greater than n. So according to your second step, you are reading the value of n. So that is n is equal to 4. Then according to your third step, you are initializing sum is equal to 0 and a is equal to 1. Then in the fourth step, you are checking whether a is greater than n. So what is a? Value is 1 and n is 4. A is not greater than 1, n. So you need to, it is no. No means what I will do? I will just repeat the steps. So what is my fifth step? Fifth step is sum equal to sum plus a. So here 0, 1. So 0 plus 1, it will be 1. Next, increment a by 1. So that is a is equal to a plus 1. So a is 1. So a is equal to a plus 1 becomes 2. Again I will go for the checking. So whether a is greater than n. Now 2 is greater than n. It is checking. It is no. Then again I will repeat sum equal to sum plus a. So now my sum is 1. A is 2. So 1 plus 2, it is 3. Then I am incrementing a by 1. So now a is 2. So incrementing by 1, I will get 3. Again I will go and check whether a is greater than n. So it is no, because 3 is not greater than 4. So again I proceed sum equal to sum plus a. So now my sum is 3 and a is 3. So 3 plus 3, I will get 6. Next a is equal to a plus 1. So it becomes 4. Again I am checking whether 4 is greater than 4. 4 is not greater than 4. So I will mark it as no and it will repeat. So on repeating, you will get 6 plus 4 is 10, and then incrementing this 5. Then now the condition is true. So 5 is greater than 4. So what it will do? It will just display the sum. So what is your sum value? It is 10. So this is the answer it will display. So every problem may not have a single solution. You can also have or think of alternate solution for the problems. So we will think the same problem with an alternate solution. So what is that? Same n value, I am taking it as 5. Instead of representing as 1 plus 2 plus 3 plus 4 plus 5, I can also represent as 5 plus 4 plus 3 plus 2 plus 1. So this will also give you the same solution. So now what is the change I need to do? As previous, I will make sum is equal to 0, but my a value will be pointing to the first value in the sequence. Now here in this sequence I have 5. So it will make it as 5. Now look at the relation between the previous value and the next value. So in that case we had incrementing by 1. Here you have decrementing by 1. So here you have 5, next 4, next 3, like that. So the relation between the next value and the previous value is decrementing by 1. So that is the change we need to do here. So my sum value is 0 and a is 5. So I need to do sum equal to sum plus a. So my sum value becomes 5. Then I will decrement my a because my next value is 4. So I decrement a by 1. So it will become a is equal to 4. Then again I do the process repetition, sum equal to sum plus a. So 5 plus 4 I get 9. Then again I will decrement a. So I will get the value as 3. And then sum equal to sum plus a. So 9 plus 3 I will get it as 12. Then I decrement my a. So 3 becomes 2. Then 12 plus 2 I will get, that is sum equal to sum plus a will bring me sum as 14. And then again I decrement my a and I get a value of 1. And then I add sum equal to sum plus a. So you get 14 plus 1, 15. So the same process, but I am approaching this problem in a different manner, in an alternate manner. So what is a change you need to do in the algorithm? So what is a change? I am initializing a is equal to n. Previously I initialized a is equal to 1 because that was the first value. So now I am initializing a is equal to n. What is the other change I need to do? The relation is not incrementing a by 1. Now it becomes decrementing a by 1. So these are the two steps you need to do change in the algorithm. Now you also have another solution for the same problem. It is a direct method. You can also use formula to solve this problem. So in a mathematical in mathematics you would have learned this problem. So 1 plus 2 plus 3 up to n is, the formula is n into n plus 1 divided by 2. So if I use this formula, so what are the changes in the algorithm? I need to read the value of n, then simply compute sum is equal to apply the formula, that's all, n into n plus 1 divided by 2, that's all. I will display the sum and then I will stop. So other in between steps will get vanished. So having learnt this logic, so this logic whether you can apply for similar problems. So just look at this sum of n odd natural numbers. So previously we saw sum of n natural numbers. Now I am just asking for n odd natural numbers. So what is the logic? Look at the sequence. So I have 1 plus 3 plus 5 up to n. So on observing the sequence you could know that always my a value is going to refer the values. So how it is related? My next value is adding 2 to the previous value. That's it. So previously it is 1 plus 2 plus 3, which means the next value you get by adding 1 to the previous value. But now here it is 1 plus 3 plus 5, which means that the next value you get by adding 2 to the previous value. Only that change you need to do. So as usual, input is n. The process is, here also you use two same variables, a which is initialized to 1 and you use the summation which is initialized to 0. Then you need to add a to the sum and store the result in sum, get the next value. Here comes the next value is 2 added with the previous value. So you will be writing as a is equal to a plus 2. That's it. So then other process is same, and when a is exceeding n, then you will get the output that is stored in the sum. So the algorithm part I have just mentioned what is the change you need to do. So other parts are same. Here instead of incrementing a by 1, you have to increment a by 2. That's it. Another one is sum of n even natural numbers. So if it is so, what is the change you need to do? Guess what change you need to do. Look at here. As previous, the next value is you get by adding 2 to the previous value. That is fine. But what happens to your first value? The first value is also changed here. So it is starting from 2. So that change you need to do here. So input is n. Now in the process, what you do is you have to use a variable to store the value in the sequence. So now I am initializing it to 2. Okay, because my first value is 2. Next I use the sum value and rest of the things are same as the previous one. So get the next value, and that is a is equal to a plus 2, and you have to repeat these two until a is greater than n, and you get the output which is stored in the variable sum. So what is the change in the algorithm? So you have to read and you have to initialize a is equal to 2, and then you need to repeat. So increment a by 2 and display the sum and stop. That's it. Now a slight variation of this problem is you can use it for finding the factorial of a number. Let us examine what is the logic. So what is factorial of n? It is 1 into 2 into up to n. So here also the input is n and the process is you need to use a variable to store the value of the sequence as similar. Initially a is equal to 1 because that is the first value of your sequence, and then here I am using another variable. The sum may not be relevant, so we need to use a variable which may tell you what the purpose of the variable. So I have used instead of sum as prod, okay, which will be initialized to 1. Why it is initialized to 1? Because it is a multiplications. So when you find the product, the initial value should be 1. When you are doing summation, the initial value will be 0. But when you are doing some multiplications, I cannot set it as 0 because 0 multiplied by any other value will result in 0. So that initial value should be 1. Next, what I am doing, multiply a to the product and store the result in the product. So product is equal to product into a and get the next value. And it is similar, okay, a equal to a plus 1, and then you have to repeat these two steps until a is greater than n. So the final output will be available in this product. So the algorithm is start, read the value of n, that is your input, initialize a to 1 and product to 1. Same steps I have written, but only thing I have changed here is product equal to product into a and increment a by 1 and display the sum. That's it. So that's it about this lecture. Thank you for watching.